All right, guys, let's get started. Okay, so we're now recording. I'm sharing the screen, so let's go to Brightspace. So today on the agenda, we've started RSA, asymmetric encryption, really great topic. And I've given you now a lot of an introduction, I should say, to the concept, the overall concept, the math background on RSA, as you have seen, is basically algebra, essentially. I still have to fill in a few things here and there, and we'll continue to do that in the upcoming weeks. This lab that we're going to do today is going to be a 2-week lab, right? So we're starting today, and we'll probably finish it up next Thursday. So I remind you that fall break is on Monday and Tuesday, so we are off Tuesday. Okay. All right, so we are here in RSA, and I remind you, I provided this link. Read through it. It's not going to be on the exam per se. It gives you some idea of some of the term projects that you can consider for this course, right? Related to the advanced algorithms, right? So in this class, I'm covering everything that is currently in place, right? That we're using all the way up to elliptic curves, but we're not covering anything related to quantum algorithms, quantum resistant technologies, any of that just yet. However, it's definitely in the area of cryptography. This is an area of great concern. So you really need to, be aware of it because you never know, right? You guys being cybersecurity students, this could be very significant. So definitely something that read the article. I think this is a really nice article. Very, very nice. It lays out a lot of the things that are going on and then use it maybe to consider a term project. It is, after all, we're on week 7. So it's time to start thinking about the term project, which is a group project groups of 2 or 3. Not really that involved. I mean, it's only worth 10% of your grade. So it's not meant to be, this is a 300 level class, so it's not meant to be that big. It's just something related to cryptography. Okay. Anyway, so that's the article. And then these are the notes, everything that we did on Tuesday. And then I do have some summary slides at some point. I will cover these. All right, so today you're going to need this script, which I think it's already on the GitHub as well. So it's probably there under RSA. This is for problem 3. This is a really nice, complete, from scratch implementation of RSA. Now, I can't say for sure that it's 100% secure. Right, right. Remember that there's a difference between theory, the math, the framework, and then the implementation, right? And an implementation, it's written by people, and you guys, know about software assurance, right? So humans make mistakes, intentional or non-intentional. And so an implementation can have vulnerabilities. But certainly it's a pretty nice piece of algorithm, and it'll take us a while to go over some of the parts of it. So this is the homework. We're going to start. I think we were going to start problem 1, but I don't think we started it. We discussed it. We worked it out by hand. So we've done that for problems 1 and 2. And so today I'm just gonna, we're gonna go over problems 1 and 2 and do the implementation of it. Okay. The other thing I've been meaning to, I have this like miscellaneous, not miscellaneous, but just a piece of code that I wanted to give you guys, and it kind of just we always ran out of time. This is not part of the homework, and it's kind of, if you remember the pseudo random number generators. So I always meant to give you this example just for your notes. It's not part of the homework, but I'm going to do that now. So I'm going to start with that today. Just go over that one so you have it. You can see how it works, and then we're going to move on to the homework assignment. Okay. All right. So let's start. The VM should be running, I think. So I'm going to Log in. Okay. Yeah, and we're gonna do this one just so that you have it, something that could become useful or later on. I'm gonna open up the terminal. Okay. All right, so let's navigate to the folder. Um, 2023. Yes, 315. All right, so I'm going to create certainly a couple of new folders for this. Okay, yeah. So this one is just going to be PRG. So a pseudo random number generator, just so that you actually see the code. This is not code from scratch. It's actually a library. And very soon, we're also going to start using the PyCryptoDome library. So that's something else that I want to test out. Okay. So PRG folder, right? And then I'm going to CD into this. Okay. This there. All right. So as I said, this is just an example of, a pseudo random number generator, PRG. Let's create a script. It should be pretty short. You can call it PRG example.py. Okay. We're going to need a library for this one called random gen. So we're going to need to install that. So the way that and also, let's see. So we're going to do, yeah, generator. So NumPy. Okay. So let's try this. So from NumPy dot random import generator, right? And the installation library, one of the ones is the pip install or, okay. I think pip3 install random gen. Yeah. All right, so let's try this. Control X1. You guys use Python 3. Okay, I have it. I've used this before. You probably got an error here. Yeah. So try pip3 install NumPy, run enter. Does that work? Is it installing? Okay, good. All right. Yeah, let it finish. And then the other one you would need to install is random gen. So as you can see, it's some kind of upgrade. So it's some kind of random generator, right? We need the usual things. All right, so any issues installing these two libraries? Okay, great. So I think that's enough. The other one we'll need to install at some point is PyCryptoDome, but we'll hold off on that. All right, so now let's go back to the code. Mine runs. Do you guys have any questions? Oh, it didn't work. What's the error? when you run the script, it doesn't. Not like. Oh, really? Um, yeah, yeah. Um, on py.random import gen. I need to see. It is. Just give me a second. It says that, and if I do Python, if you guys do this, what version of Python do you have? Do you have 3.9? Here, if you look, see here. What number does that say? If you type the command Python, 3.8 is what you guys have. Okay. Why do you have 3.8? Okay, so that's an issue. It says here it builds on Python 3.9 or above, which I have 3.9. So everyone has 3.8 Python? Okay. So you can try to install this, which is Anaconda. It's a environment manager that we can use. So you can go to anaconda.org or .com, I guess. Yeah, go to anaconda.com. And then download. Should be down here somewhere. Download at the top. Is it? Yeah, let me just see. Yeah, let's try that. And it should just be a script. It's a shell script. It's free, so this should not. um, and then try. This is 1 gig. This is. Yeah, try this one. Yeah, and should give you this. You see there's like a shell script that tries to download. Everyone with me? So if you get this, if you install this, it's a environment manager, and it's a very handy thing to use. Do you guys understand what I did? Do you want me to repeat it? Yeah. All right. So I do this in 372, but I think some of you haven't taken that course before. So um, we're having issues with libraries, versions, and things like that, right? So go to Anaconda. And we'll go to anaconda.com. So free download. Is a free minimal installer for Conda. Small bootstrap version is includes Conda Python. Okay, so then click on download here. Takes you to this. So download Anaconda distribution or mini Conda by choosing the proper installer for your machine. So then it would be we're on Linux because you're in the VM. And then just use the installer here. And this gives you a download, which is this one. Do you guys see that? So you can click on K and save, actually. I think it opens on the terminal, but maybe just save it, guys. Do you guys understand? So you save it, and then did I not click on save? Okay. And then if it's already in the downloads, do you guys see it there? Yeah, this one, right? Miniconda.sh. Everyone with me? So now open a terminal, another terminal. We're going to navigate to that downloads folder. Downloads. And then uls-l. And you can see I have two. So the first one, Miniconda sh. Do you guys see that? Right? And then just type then sh. It's a script, mini. And let me do sh mini tab. Um, .sh. So make sure it's the whole name. Everyone with me? And then you should be able to hit enter. If it gives you an issue, you have to use the sudo permission. That's all. So try it like this. It might require you to use sudo for installation. And then it should start installing. I already have it, so is it trying to install right now? Let me know if it finishes. If it finishes, then once you'll open up a terminal and then you should see that the word base in parentheses. And that tells you that the program is installed, right? Download this. Okay, yeah. You can undo. It's got some questions. Yeah, wish to update your shell profile. Change content. Startup and change. So just say yes. Oh wait, change. Default. We press enter. Okay, yeah, press enter. That's it. Yeah. So just press enter. Did it finish for you? Yeah. And can this determine that one and open? So you ran the script successfully, right? And then what should happen is if you run this, no errors, you just said no. Then when you open, maybe close all terminals and try again. But you should get a terminal eventually that just looks like mine, where it has this in front of it that says base. Do you see that? And that means that it's installed properly. You don't have it like that. Maybe you restart the computer then, and so the change takes effect and see if we get that. Any questions, guys? Did you guys try running it and see if it installs? Yeah, so restart the VM. Let's see if no luck. Okay. Oh. If you type the command, if you type the word conda, what does it bring up? Does it bring up like instructions or does it give you an error? Command not found. Okay. So it did. Downloaded good. Okay. Um, we installed the mini conda. I wonder if it was the other one to install.
Oh, I have to base the show up.
You got it?
Yeah, you have to run a command.
Which command?
That one. Storage command. Hmm. I thought what that one question was. So like,
That might have been, yeah. So you should have, yes. Or it's later. Yeah. No, but this solution.
And then Conda does do stuff after that, yeah.
Yeah. Where'd you find that command?
I.
Yeah.
I just do.
Do you have the command on the board?
What's but in bullets?
Source?
Space, tilde, slash, mini Conda 3, slash, bin, slash activate.
Try that. See if we get that base. Did you guys get the base? Who, any of you, any questions, guys? So we can move on, or you all got the base? Okay. All right. So it sounds like you all have the base now. So this is a really useful thing. You should all be here at that point. All right. And so what we can do now is we're having issues with libraries, right? So we were trying to install something and the version of Python does not work and NumPy and so on. So Anaconda is a really nice environment manager that helps you um, to install, you create an environment, and in that environment you can have Python 3.9 and NumPy 1.22. But then you create another environment, and in that one you can have Python 3.11 and NumPy 2. Do you see what I'm saying? So it allows you to manage dependencies really well, right? So we want to try this out. So I'm gonna do Conda environment list. Okay. So this is something really important that, as we start adding more libraries on cryptography, we may need to just use these environments. And you just switch from one environment to the other whenever you need it. And that way, creating new code with new libraries doesn't mean that you have to update and then it breaks all your other code, right? So your code continues to work. All right. So we're going to create an environment. So Conda So we're going to say conda create. I have these commands actually, so you guys can reference them. On the GitHub, I have a repo for these kinds of commands. So let's go to repos, and you can go to should say Unix or Linux. There should be a repo here that says Unix or Linux. Oh, there it is. So Unix Python scripting. Okay, you can click on that. And then the commands should be here, conda commands. All right, and so these are the generic commands that you can use for Anaconda for visualizing your environments, activating and deactivating environments, and creating one. So conda activate, deactivate. So we're gonna do conda create. Conda create dash name. Pi, the version. Let's try. So this says this says that it needs 3.9. So let's do that. So you guys have 3.8 for some reason, but let's try to have 3.9, which is what I had, and it worked for me. So this is just the name, but as a convention, I always put the version of Python here. And then you can just say something like crypto, just to remind you what this environment is usually for. Conda create dash name, Pi39. And then you're going to say the version of Python, and this is really important. So something like 3.9. Do you guys see that? Everyone with me? Everyone got the command? So hit enter. Okay, so you should get something like this with a whole bunch of libraries. Yeah, okay. Hit yes, hit enter, and it should start installing all these libraries. So that's just installing. So you're literally installing the whole of Python in this environment. Okay. Okay, so now you should get base back. Okay. So what we want to do is we want to activate this environment, Pi39 crypto. So I'm going to do conda activate. And you can actually look at the environment. So you can say conda environment list. Okay, so here it is, Pi39 crypto. So now you can try conda activate Pi39 crypto. And that should change the word base to Pi39 crypto. That works? Perfect. All right. So now there you are. So now you know how to change environments, right? So whenever you have some library, whatever it is, um, you don't have to just upgrade everything on your system, right? And then the sad part with that is what about all the code you've done before, right? Then it's going to break. So you don't want that issue. All right. So in this environment, then now, hopefully we can just easily install the two things that we needed and they'll be supported. Okay. So that's the idea. Do you guys understand? So otherwise we have to like figure out the specific versions. So we needed NumPy and we needed random gen. So let's install. And here, actually, we can use pip also, which is another very nice feature. Now we can use pip to install all of our programs, and it makes everything a lot easier. So pip install NumPy, because this version does not have NumPy. Okay, so go ahead and try that out. NumPy 2, okay, which according to this, it supports. Okay, and that, we're back in the environment. Everyone good? Okay. And then the last part, let's try random gen again. So pip install random gen. Okay. What about you guys? Did you get to this point here? All right. So if you got to this point, then yeah, so we overcame the problem, right? So the problem seemed to have been that we were using Python 3.8. But this is the beauty of using Anaconda. This is a very common thing. Virtualization is kind of part of this encapsulation. But yeah, so the idea here is we can create any environment that we want. So now we're here in our PyCrypto environment, and this is independent of a folder. So this is, those are two separate things. So now we can go back to our folder. We just have to figure out where we are. Okay. So we need to navigate to the desktop. There. Whoops. ls-l. And we need to go to the course. So CD fall 2025. Clear. And let's go to that PRG folder. All right. So we have our code here, and now we have the two libraries that we needed. So let's test to see if it works, right? So we're going to try to import all the libraries from the script. So I'm going to do nano PRG example.py. I have, you no longer need pip3, you're not, or Python 3. You now just use pip and Python here. So let's bring in the libraries to make sure everything works. So the first one should be from numpy.random import generator with uppercase G. Okay, so you take a look at this one. Then we're going to do from, whoops, lowercase, from random gen import. And there's a thing called cha-cha. So cha, right? Like that. These are just, like I said, blowfish or whatever, these funny names that hackers like to use when they create these things. But it's just some kind of algorithm for encryption. And we're going to import another one from random gen import AES counter. So these are just some of the things that we would need Okay, these three libraries. So Control X, Y, clear. All right, so now let's try this out. Python. All right, if you get this, then it means everything worked. There were no errors. So it's good. Great. So as you may have noticed, so all semester so far we've been writing everything from scratch, and that has been great. And we're going to continue to do that to learn more about the cryptographic algorithms. But as we start moving into more advanced things, more application side, we have to use libraries, okay? Such as these, and these libraries, of course, will require more installation. So Anaconda definitely play with it, become familiar, look at the commands that I provided, etc. All right. All right. So all of that work just for like 3 more lines of code, right? But that's how it is. So we install all those libraries, and now we're just going to try to run this and try it out. So we're going to try to get the code working, and then we're going to talk about how this is a pseudo-random number generator and go back to this concept, and so that you guys get an example. All right, so let me just bring it up here. So this, remember, it's a stream cipher. As you can see, you saw the word AES, so it's based on some of that. Okay, so we are going to need some kind of an object, a generator, essentially. That's what we need. So let's go back here. So now we're done with the libraries, and we need a generator. So let's call it gen. Good name. Gen. And it's going to be equal to generator. So that's this keyword up here from NumPy, right? We instantiate this generator, and we're just going to specify that it should use that cha-cha one or AES counter. So it can use either one of these. So here I'm going to do AES counter. Okay, so AES counter. We're going to give it a number, a type of a seed number, 1, 2, 3, 4, 5. And then we're going to specify a mode, right, which is going to be sequence. Okay. So sequence just like that. Okay. Then we can print this object gen just to see what it returns. But we haven't yet used it as a pseudo random number generator. All right, so Control X, Y, Python. Well, this should just be a warning. Okay. So now let's try. I'm gonna do a print here. Print done. Control X, Y. Yeah, so it runs the print. Okay, so that it's a warning. Now, essentially, we're going to try to generate, the sequence, right? Okay, so let's try to do that. I'm gonna need a for loop to control it. So I'm gonna do here. So in here, I'm gonna do for I in range. Let's just do 10. 1, 2, 3, 4. And I'm going to create a result. So I'm going to use that keyword gen dot random times some number, like 1,000. Okay. All right. And now we're just going to print this result and see what value we get. Print int res, like that. Do you guys see that? So we're just generating 10. Okay, and we're printing it to the screen. So I'm going to do Control X, Y, enter. And there we go. Do you see that? That's it. I mean, what was a pseudo random number generator? So essentially, it had to be pseudo random, right? And it had to be a generator. Something that, yeah, go ahead, please. Yes, a good question. Exactly. Any other questions, guys? Do you see the idea? So how would we use this? So well, how would you use it in theory? Remember, we talked about it, right? It's the thing that extends the key to be larger than or as large as the message. So we use it for a stream cipher, right? So yeah, so this is the code example, essentially. Try something else here for I in range. 10 res equal gen dot random thousand. Let me do this differently. If I gave you this on the exam, on the second exam, this could be a problem on the exam. And I tell you, this is supposed to be a pseudo random number generator. And I have Bob has this and Alice has this. Is it correct or is it incorrect? What would you say? Do you get that? So Bob is the first one, Alice is the second one, and they're trying to use cryptography in some way using a pseudo random number generator with these parameters. These are the two outputs. So is it correct or is it incorrect? And why? You have to think of the purpose of a pseudo random number generator. Yes, go ahead. Well, well, I mean, I just intentionally made it into an integer. So it's not that. We have the bits in there. We can XOR them. But what do you think? Is this the way it's supposed to work? How is it supposed to work? How about that? I ask you that question. How is a pseudo random number generator supposed to work? What are you doing? It's symmetric encryption, right? So Bob has that pseudo random number generator in a message. And on a byte basis, you're going to encrypt, correct? Okay. And then Alice receives, and she has to essentially do the same, right? Be able to do what? Decrypt it, right? So exactly. So here you have the bytes, the key bytes, and the plain bytes, and then you're gonna receive what? The cipher bytes, and you're going to XOR it with these bytes, and you should get the plain. Do you guys agree? Everyone with me on that? You understand the concept? All right, so I'm not going to take it further than this, but this could make a nice homework at some point or something like that. But do you guys understand the idea of how they work now? Any questions? All right, great. So yeah, so I provided then an example in Python of a pseudo random number generator. We can see that we were able to, now we're using libraries. We were able to generate, that is what? That's just a key, correct? The pseudo random key based on, as you said, 1, 2, 3, 4, 5, that's actually the shared secret that they somehow need to exchange via RSA or something like that. All right. All right, so we've completed that one, so that's good. So that could be on the exam or something. Also, it could be on the scavenger hunt, so make sure you know how to use this one, right? Because I could take a message and encrypt it this way. So one thing I can do on the scavenger hunt is hide that 1, 2, 3, 4, 5. And so, but I'll say I'm using a pseudo random number generator. Here's the code, by the way, which will be exactly like this one. And then what you have to do is generate that pseudo random key to encrypt or decrypt the message. Okay. So yeah. All right, great. So this script has been covered. So now we can move on to the RSA lab. As I said, no homework this week, right? So we're just starting it. Since this is kind of a different topic, I'm going to end this video. Just going to call this one pseudo random number generator.